This hit and run econometrics is about the t-test and used and new cars. We have these outside experts that come in from time to time. And one time when they came in, they made this recommendation that faculty should make a more concerted effort to involve students in their own research activities, bringing their own research into the classroom. So that's what I'm doing right now. I'm doing this not because my research is brilliant, rather, quite the opposite. We have in our department some really brilliant econometricians. I'm not going to mention any names right now, but they are really good. And their work is so sophisticated, it doesn't really make great examples for an introductory class. But here is a great example for an introductory class, a rather unsophisticated article that I wrote for the Journal of Consumer Affairs called The Cost of Driving a Car Off the Dealer's Lot. You've probably heard that a car loses a lot of value when you drive it off the lot because now it can no longer be sold again as new. And instead, what I find here is that the loss of value is not unique to new cars and is actually more pronounced in older used cars. So let's just do an example adapted from this paper. It says here, in a sample of 72 car models, the average new car lost $1,320 of its value when driven off the dealer's lot. The average 1-year-old used car lost $928 of its value when driven off the dealer's lot. And so the new car loss of value at 1,320 was greater than the 1-year-old car loss of value at $928. But was the loss statistically significant? In this sample, X bar, that mean, let's make that bar a little clearer there, X bar was $928. Mu zero was $1,320. The S there was 320, and the number of used car models, new and used in the sample, was 72. So what we do here is we write out the T statistic, one of the very few things that I call on you to memorize. It's X bar minus mu zero over S over the square root of N. And our null hypothesis here is going to be that the new and used car loss of value is the same. What? Everybody knows that's wrong. The, new and used values lost when you drive it off the lot are the same. Anybody in the used car business would tell you, nah, that can't be true. But then you remember, we're doing this odd convention of hypothesis testing. We don't try to prove what we think. Instead, we assume the opposite and try to disprove that. So the opposite is that X bar and mu are the same numbers, so close together that there's just a little statistical noise involved there. Now it's just a matter of filling in the formula. $928 minus $1,320 all over 320 over the square root of 72. And that comes out to minus 392. That's negative 392 over 37.7. And that comes out to a T statistic of negative 10.4. Now, under the null hypothesis, these numbers should be very close to the same, and that T statistic should be close to zero. So I want to use the exaggerated scale of this horizontal line here across the bottom to make a point. And the point is this, that if the null hypothesis is correct, and those new and used car losses of value really are about the same, we should have our test statistic, the T here, coming in really close to zero. And we want to figure out, what does this curve look like? Well, it's that, kind of bell-shaped curve with fatter tails. And at this point, we pull out our trusty t-table and figure out, okay, for that sample size, what are the critical values that we're looking for? We always round down, so n equals 72, we round down to 60, and we find that our critical values are 2.000 and 2.660. So we put the t-table away, we won't need that again. What that's telling us is that if the null hypothesis is correct, and those new and used car losses of value are about the same, most of the time we're going to have our results come in between plus 2.00 and minus 2.00. That is, if the null hypothesis is right, 95% of the time, we're going to be somewhere between those two numbers. Further, if the null hypothesis is correct, there's that other number, that plus 2.66. There's that negative 2.66. If the null hypothesis is correct, then 99% of the time we should come in between negative 2.66 and positive 2.66. So if the null hypothesis is correct, we're going to be getting a bunch of tests that come in right here in this region. But what is the value that we found? The value that we found was negative 10.4. The value that we found was way down here, minus 10.4. And so what that says is we can soundly reject the null hypothesis. Hey, we never believed it anyway. But we can soundly reject it. We can say, it's almost impossible that new and used cars lose the same amount of value when driven off the lot based on the evidence of this sample, because it's throwing off a t-statistic negative 10.4. And hey, 95, 99% of the time, if the null hypothesis were correct, we would be up there. So what we do is to reject the null hypothesis and assume what we believed all along, which was that new cars lose more value when they're driven off the lot. In fact, table here from the article, we showed that, the best deal, if you're just looking for the smallest loss of value, is in a 1-year-old used car. They lose the smallest amount of value when you drive them off the lot. A new car loses more value, and wow, a much older car loses a whole lot of value. True story, just to cap this off, I will tell you, through my work, I worked with an adult who had reached actually some age in her 30s and had not learned to drive. It happens. And in order to practice driving, she wanted an old beater car. And in the prices of the time, that would be a car worth, maybe $800. She didn't want to drive her husband's car and mess it up. And so she, looked in the newspaper. Hey, how about this one? There was a car for sale. It was a 1972 Toyota Corolla at Weiss Auto Exchange on South Main Street in Harrisonburg. And, her helper said, let's go make a deal on it. And this $800 car, according to Bob Weiss, was only worth about $400 after driven off the lot. So it lost half its value. That was a huge loss on that old beater car. And it was more of a loss than on certainly newer used cars. And it was an even bigger percentage loss than on a new car. This story has a happy ending. The adult involved did learn how to drive, didn't mess up her husband's car, never hit anything on that $800 Toyota Corolla, but felt really good about driving a less valuable car in case she did back it into a mailbox somewhere or another. She is today a happy driver with a perfect driving record. That is the hit and run on the t-test on used and new cars.